You might remember in the Secrets episode where we learned that functions are first-class citizens in Elixir. The guessing game exercise introduces us to two more ways Elixir treats functions as primary language features. First, arguments can be matched against. I alluded to this in the language list exercise where we deconstructed a list right in the arguments. We'll see another example of this in the guessing game where arguments match each other or specific values. We'll also see guards. Guards are attached to functions and used to determine if the function could be executed. In other languages, you would have had to define differently named functions and use a case statement to decide which one to call. Argument matching and guards eliminate that boilerplate, producing more readable and maintainable code. Created a notebook for the guessing game in my NotebookLM using just the link from the Exercism exercise. I then asked it to create a video and a quiz with no prompting, just let it do whatever it felt best. There'll be a link for the video in the description box below. And I think it did a pretty good job. There's a couple of typos in the slides, but it's pretty amazing and pretty insightful for not providing any guidance whatsoever. Let's take the quiz. In Elixir, determine which function clause to invoke when a function is defined with multiple clauses. It tries each clause from top to the bottom, executing the first one that matches the provided arguments and guards. That is spot on. It compiles them into a single function body with complex logic. No. It executes the clause that has the most specific pattern match, regardless of its position. No, it is top down. It randomly selects one. No, it does not randomly select one, so it would be A. What is the primary role of a guard which begins with the when keyword in an Elixir function clause? To define a default value? No, that's handled differently. To mutate a global or cause a side effect, guards are not allowed to have side effects, so no. To provide additional conditions on the arguments that must evaluate to true before the clause is executed, that is correct. And to catch or handle runtime errors, guards have nothing to do with error handling. So, C. In the context of the guessing game's compare function, why must the so close clause be defined before the too high and too low clauses? Remember, the functions are evaluated from top down, so if you need to put the more specific clauses before the more generic ones, so close has to come before too high and too low. So the compiler raises an error. No, that's not true. It's a stylistic convention. That's not true. It's not a performance optimization either. So because so close could match those other conditions of too high and too low, it has to match the first clause it finds. Right. If you define a function that has a def process data, what does Elixir do during compilation? All right, well, first off, there should be two slashes here in this definition, indicating that the argument is named is data and the default value is no data. And I think this question's a little bit over the top for what we're supposed to be learning. The compiler actually creates two versions of the function, one without arguments. When that one's invoked, it passes in the default to the version that takes one argument. It doesn't create a single function. It doesn't create process data 0 because then you'd have no way to pass in an argument of your own, and it has nothing to do with tuples. According to the source material, which is the correct syntax for defining an argument, a default argument for a function that has multiple clauses, I see. So the default argument must be defined in every. No, that is decidedly not the right approach. They cannot be used with functions. That's not true. They certainly can. A function header, a signature without a body with the default argument, is defined before the function clauses. That is true. The default argument is defined only in the first clause and applies to all subsequent ones. No, you have to define a header. Which of the following function calls for the compare function is intended to produce the response make a guess? Well, this has a guess, so it's not that one. 5 with nil is, we haven't discussed nil, so that's not it. Compare without any arguments at all leaves out the secret, so it can't be C, so it's got to be D. What is the established convention in Elixir for a variable in a function definition that is not used in the function's body? So we saw this in our language list exercise. You prefix it with an underscore. You should not remove it entirely. That changes the signature. No, the preferred is the underscore, so it's nothing to do with the compiler and syntax. And we don't have an unused keyword, so it is definitely the underscore. Which guard condition correctly implements the logic for the so close response in the guessing game? Well, so close is it's either one less or one more, so it's not A. It's not when they're not equal. There's a whole range of responses for that. When the secret number is one less or one more, so that's certainly a possible answer. When the absolute of guess minus the secret number is 1. This is also a legitimate guard clause. Just turns out that for the instructions they state not to use any advanced functions, so they're looking for C here, although D could also work. The documentation states that guard functions must be pure. What does this imply? They must be done in the same module as the function? That's not true. They must be written in a special restricted subset of Elixir. Maybe, but I doubt that's what they're looking for. They can only work with integer types. No, that's not true. They can work with all the primitive data types. They must return a Boolean value and cannot cause any side effects like mutating a state. That is definitely what they're looking for. All right, we're going to use VsCode to program the guessing game exercise. We're going to introduce GitHub's Copilot Chat as our agent and learning assistant, although we're going to use it more for process in this case than we are for learning, just as a warm-up. So Copilot Chat, Copilot is one of Microsoft's AI agents, and you can install it into your VS Code by going to your extensions and then searching for Copilot Chat and then install. I already have mine installed, so we'll work with that. Open chat with this icon in the top that says toggle chat, and that'll give us a window where we can type in the message box down here and Copilot will respond. Built-in chat agents like this, and there are many, but built-in chat agents like this have the advantage of being able to see your source code, and that would be different than if we were to just jump out to ChatGPT or other. They don't see your source code, so you would have to share it with them, but built-in agents like this can, so that's one of the advantages. So what we're going to use it for is, instead of us having to understand the test file, I've built a prompt that I'll include below. It says, this is an exercise from exercism.org. I'm learning how to write Elixir. I'd like you to help me by running the tests. Don't fix the code if they fail. A simple yes or no response is all I need. Do the test for the first instructions pass. We should be able to run this now. Of course, this should fail because we haven't written any code yet. But what we should see is Copilot saying, all right, I see that the first instruction is for task ID 1, so I'm going to run mixed test only task ID 1. This is the exact same command we typed in the last episode, so we're going to allow this to happen. And then down in a terminal, Copilot ran that for us and says, no, they don't pass. So there we go. We'll be able to use this as we go forward. So let's get to the exercise. So in the README, the first instruction is You're creating an online game where the friend can guess a secret number. You want to give some feedback, right? So when the response matches the secret number, we want to reply with correct. Right. So in our game, we're going to write a version that takes the secret number and the guess. Now, I'm going to show you, frankly, how I did this first, and then we're going to fix it, if you will. When secret number equals guess, do correct. Get some more real estate here. Now we can ask again if our test passed. All right, first one passed. Very good. Now, frankly, this is how I programmed this the first time I looked at it, and we can do better. We can use the argument matching function and simply say when the secret number is both values, then it's correct. Very good. On to the second. Modify the compare function to respond that are too high than the secret number. Should reply too high. Okay. So we will take this when secret number is less than guess, then we want to say too high. Oh, great. Well, autocomplete has jumped ahead of us, so we'll keep the code rather than watching me type it over and over again. We should be passing when the secret number is less, we should get too high. When the secret number is bigger, we should get too low. And we want to fix this to match the instructions. As we saw in the quiz, although this is legitimate, this is not the way they had intended you to write this clause. They had intended it to be when the secret number plus 1 equals guess, or secret number minus 1 equals guess, then we want so close. And as we learned from the quiz, we'll have to move this up above too high and too low because these conditions will match before this one does. But let's work through and asks, how about the tests for instruction number 2? Do they pass? And you can see here it's going to run test with ID 2. And we expect 4 to fail because the too close is, the so close is below the other two compares. So if we move this above the others, very good. Okay, so too low, So close. We've done. When the response, when there is no guess. All right, well, this one takes a couple of jumps. So what we want to do is, this is where it gets into the default value. We want to define a function head that includes a default value. So if this is called, if compare is called without a value for guess, we'll get no guess. Then we can say, hey, if we compare secret number, if compare is called with a secret number and no guess, then we reply with make a guess. So it's sort of a two-step process. And this is preferred over having a one-arity version that is just a function that takes secret number and then all of these two-arity versions. And we see here from the quiz that we prefixed secret number with underscore because we're not using it. What are we on? Number 5, I think. Oh, wait, why are you complaining? Oh. And you can see for a while it was doing really well. I had said a simple yes or no is all I need, and it was doing really well at that Copilot, that is. But now it's saying, yes, the test for instructions 5 passed with 0 failures. So, you know, it's in the right direction. If I didn't have that, it tends, that statement to say that I simply want a yes or no answer, it would give you a paragraph about the results, and it's not what I wanted. Oh, is that it? Is that all of the tests? All right, so if that is true, we don't want this. We certainly don't want that left around anyway. Okay. We'll just ask if all the tests pass now. Very good. All right, so the same name function. Here's the default value of no guess. Here we're saying if the guess argument exactly matches no guess, then this is the compare function to run. Here we're saying if the two arguments are exact same number, then this is the version of compare to run. Here we're saying if it's within 1, this is the version of compare to run. And of course, the first one that matches the arguments and the guards is the one that's executed. And so we will down and at the very end with, well, then too low. And if you could come up with a scenario by which none of these matched, you'd get an exception. Using Copilot Chat to facilitate tasks like running tests is an underrated but highly valuable technique with AI agents. You saw me run tests in the lasagna list video, but I needed to understand the task ID structure. You can see that with AI, I didn't need to know any of that. I simply asked it to run the tests for the instruction I was working on, and I had a more natural language experience. Watch the NotebookLM video, it's quite good. Give this video a like to let me know these are valuable. Join me the next time for the kitchen calculator exercise, where we learned about tuples and more pattern matching.